Hello, my name is Mr. Chu and I welcome you to my study room. Today I'm solving objective questions 1, 2, 15, 20, 26 and 31 of the 2025 WASSCE Core or General Mathematics paper written by Nigeria. I put these questions together because they appear to be under the same topic: length, area and volumes. With this paper, I've decided to do something a little more differently. There are many instances where when you are learning about a topic, students ask, how does this apply to our daily lives? So I've decided that for each question or each set of questions I'll be solving, I will try to say something small about the real life applications of those topics. And that leads us straight to the meaning of length, area and volume and their real life applications. So introducing us to length, area and volume, I have a little poster here that summarizes what each of them means, and then we go to the applications of each of them. And we move straight to the first one in the yellow about length. So length is just a one-dimension measurement. And some of the tools or instruments used in measuring length are either a ruler or a tape measure, as we can see here. Then when we move to area is two-dimensional. So for example, if you are measuring the area of the field in this picture, then we are going to measure the length and the width. So area is length times width. And then the volume is three-dimensional, where we'll be looking at the length, the width, and the height as examples. What are the applications of each of them? Like I said earlier, length is one-dimensional or linear measurement, and in real life, length is used in measuring boundaries, distances, and feet. And we would like to look at its application in three different aspects of life: home improvement, fashion and textiles, and infrastructure. In home improvement, you go out to buy a sofa and you are not sure whether it will fit a particular corner of your room or not. If you know the length of your room or the length of the sofa, you will know whether it will fit exactly where you want to put it or not. And also, you need some baseboard for renovation in your room. If you know the length of your room and the length of the baseboard, you will know how many meters you need. And then in fashion and textiles, tailors use precise body measurement to ensure clothes fit comfortably. And in manufacturing, length determines how much fabric is required for production run. Then when we come to infrastructure, civil engineers use length to calculate the amount of asphalt needed for a highway or the span required for a bridge. These are some of the applications of length. Let's now see some real-life applications of area. Again, from one-dimensional space, which is length, we move to two-dimensional space, which is area. And area measures the amount of surface a shape covers. And we are looking at three areas of application here: agriculture and landscaping, real estate, and then interior design. In agriculture and landscaping, farmers calculate the area of their field to determine how much seed to buy or how much fertilizer is required to treat the soil effectively. So that is application of area in agriculture. And then real estate, property value is almost always tied to square footage. Understanding area helps you verify if you are getting what you pay for in a rental or purchase. Right, so if you have a fair idea of the area of an apartment you are renting or buying, or a house you are renting or buying, then you first of all have a fair idea to know if that is the size you're looking for or if you are getting value for money. Because let's say you are comparing two or more properties, you can use the area to compare to know which one gives you value for money. Then when we go to interior design, you use area to calculate how many cans of paint you need for a wall. That is area equals length times height, or how many boxes of tiles are required for a kitchen floor. So these are some of the ways you can apply area in real life. especially if you like to do things for yourself sometimes. Let's go to the last one, which is volume. As we progress from 1 and 2, volume is a three-dimensional space, and volume measures the amount of space an object occupies. And we can say that volume is the capacity of an object or space in the thing. And we are going to look at 3 areas of application of volume. The first one is logistics and shipping. Courier services calculate the volume of packages to determine shipping cost and to figure out how many boxes can fit inside a shipping container. So that is volume. And in cooking and chemistry, recipes and chemical formulas rely on volume. That is either liters, milliliters, or cups to ensure the correct ratio of ingredients or reagents. And then the last one is in resource management, where engineers calculate the volume of a reservoir to know how much water a city has in storage, or the volume of a fuel tank to determine a vehicle's range. So these are some of the ways a student can apply this concept later in life. And we can now move on to the first question. And the first question reads that the volume of a cone of height 18 centimeters is 8,316 centimeter cube. Find the base radius of the cone. Take pi equals 22/7. To understand this question properly, we'll look at the key information or facts from this problem, which are that the volume is 8,316 centimeter cube, and this is the volume of what? A cone. And also the height is 18 centimeters. And then the last thing we are looking at is to find the base radius of the cone. And then an important information is here. Let's take pi to be 22/7. We will first start by writing the formula for the volume of a cone, because that is what we need. We are going to use the formula V for volume equals 1/3 pi r squared h. And we are going to plug in the information given in the question. So the volume is 8,316, and that equals 1/3 times pi has been given to be 22/7 times r squared, since r is what we're solving for, and then times the height given in the problem, which is 18. And this becomes 8,316 equals, let's multiply all the numbers. We'll do 22 times 18 first. 22 times 18 equals 396. So 396 over 3 times 7 is 21 r squared. To make r squared a subject, this comes here to multiply this, and then this 396 come to divide both of them. So that will give us 8,316 times 21 over 396, and this will be equal to r squared. Using our calculator, and that gives us 441. So 441 equals r squared, and that can be written as r squared equals 441. And taking the square root of both sides, this and this goes away. We have r to be equal to square root of 441, square root of answer, and that gives us 21. So r equals 21 centimeters. And looking at the options, that is option A. Let's go to question 2. Question 2 reads that a square has diagonal length of 10 centimeters. Find the perimeter of the square. Quick information here. We are talking about a square. That's the first information. And the diagonal is 10 centimeters. And then we are calculating the perimeter of the square. Now, let's put all this information together. I will first start by sketching a square. So we take this to be a square, and some of the properties of square are that the sides are equal, all four sides are equal, and it has four right angles. And then the question said the diagonal is 10 centimeters. So let me write that here. And then we're solving for the perimeter, which is the addition of the length of sides. So let's call each side x units or x centimeters. And this is the problem. All sides are equal, but we don't know even one side. So we're going to solve for the side first, then we can add all. And I'm going to use two ideas here. The first one, which is the shortest to understand or the easiest, is the idea of special right triangles. And before that, this is a 45, 45, 90 right triangle, which means that this angle here is 45 degrees, and this is also 45 degrees, and this definitely is 90. So one of the special right triangle principles says that if we have a 45, 45, 90 special triangle, as I have it here, and each side has the measurement x because they are equal, then the hypotenuse will be x square root of 2. And looking at this part of our square, it forms a special right triangle. So comparing the two of them, meaning this side and that side, it means that x root 2 will be equal to 10. Making x the subject, we divide both sides by square root of 2, square root of 2. So this and that goes away. We have x to be equal to, we cannot leave this way, so we have to rationalize. You can use your calculator, but I have just decided to multiply. So the numerator gives us 10 root 2, and then root 2 times root 2 gives us square root of 4, which gives us 2. So 2 divided 10 5 times, and x will be equal to 5 root 2 centimeters. So it means that each side of the square is 5 root 2. So this is 5 root 2, 5 root 2, 5 root 2, and then 5 root 2. So the perimeter, which I'll call P, will be equal to, either you add all of them, I just do 4 times 5 root 2, where the numbers can multiply, or I can use the calculator, will be equal to 20 root 2. And looking through, that is option C. I promise to use two approaches. So alternatively, we already said that this triangle has 45 degrees in here, so we can use the idea of SOHCAHTOA. So if you have this, just redrawing it so that you can see it well. This will be 45 degrees, this is 90, and this is 10 centimeters. So we're solving for the side x, or we can use the down, it doesn't matter, whichever. So using this, we know that this is opposite and this is hypotenuse, right? So using SOHCAHTOA, which of them involves opposite and hypotenuse? I'm sure you'll tell me is sine. So we'll write sine 45 equals, opposite is x over hypotenuse is 10. Multiplying both sides by 10, the 10 comes to multiply the sine 45. So we're having 10 sine 45 equals x. And write on our calculator, 10 sine 45 equals 5 root 2. So x equals 5 root 2 centimeters. And then we go ahead and solve for the perimeter. Let's go to question 15. Question 15 reads that the radius and height of a circular base cylinder are 8 centimeters and 14 centimeters respectively. Find its curve surface area. Take pi equals 22/7. And the key fact from the problem are, we are talking about a circular base cylinder and the radius is 8 centimeters while the height is 14 centimeters because of the word respectively here. And we're solving for the curved surface area. Let's not forget this very important information. Take pi equal 22/7. We'll start first by quoting the formula for the curved surface area of a cylinder. So using CSA for curved surface area, that will be 2 pi RH, where R is the radius and H is the height. Taking this particular cylinder, the question said we should use pi to be 22/7 times the radius is 8 and then the height is 14. I'm not even going to stress because the calculator is here, so let's put that into it quickly. The most important thing that you make sure you put it just as it is written, and then equals 704. And remember, its area we are talking about is 2-dimensional, so centimeters squared. And looking through the option, that is option B. Let's go to question 20. Question 20 reads that 2 ball bearings have volumes 1.6 cubic centimeters and 5.4 cubic centimeters. Find the ratio of their surface areas. Things to pay attention to. There are 2 ball bearings and then the volumes are 1.6 centimeter cube and then 5.4 centimeter cube. And then we have to find the ratio of their surface areas. Again, this question measures 3 dimensions, volume. So according to the question, let's make this volume V1 and then let's make this V2, since both of them are volumes. And that's not all. Since ball bearing is measuring volume and that is a sphere or is spherical in nature, we are going to use the formula for the volume of a sphere, which includes radius, and then also, because you are calculating the surface area, we will need area as well. So let's define both of them. We will let R1 and R2 be the radius of each of them respectively, and then A1 and A2 be their surface areas. Now let's start by quoting the volume of a sphere. So volume of a sphere using V equals 4/3 pi R cubed. And back to the question. The question said the ratio of their volume. So V1/V2 is going to be 4/3 pi R1 cube over 4/3 pi R2 cube. And the question said V1 is 1.6 and then V2 is 5.4. So this and this are the same, so they cancel out. We'll have R1 cube over R2 cube will be equal to 1.6 divided by 5.4. Let's use the calculator. 1.6 over 5.4. That equals 8/27. So this is 8/27. Let's just go ahead and find the radius for each of them. So this means that R1 cube over R2 cube can also be written as R1 over R2 all cube, since they have the same exponent, equals 8 over 27. Let me write it out. I'm taking the cube root of both sides. R1 over R2 will be equal to cube root of 8 over 27. And R1 over R2 will be equal to cube root of 8 over 27. So I go to shift and I use this one. I put 3 in there and I bring fraction 8 over 27, and that equals 2 over 3. So that is 2 over 3. It means that the radius of one of the ball bearings is 2 and that of the second one is 3. And then the question asks us to find the ratio of their surface areas. So we'll start by writing the surface area of a sphere to be 4 pi r squared. So the ratios, which will be A1 over A2, will be 4 pi r1 squared over 4 pi r2 squared. And then again, 4 pi is common to both of them, so they can cancel out, and that will be left with r1 squared over r2 squared. But we know r1 to be 2 and r2 to be 3, so we are squaring both of them together, and this will be equal to 4 over 9, and written as a ratio, that will be 4 to 9. And looking at the options, that will be option A. There are some other ways we can solve this problem. Someone, after doing the volumes and getting the R1 and R2, the person can just say that the ratio of the volume of two objects will be the same as the ratio of the cubic radii of the two objects. So instead of going through all these calculations here, the person will simply equate the ratio of the cubic radii to the volumes and solve for R. And then again, the ratio of the areas or surface areas is the same as the ratio of the square radii. So the person can still equate them straight without going through the area. I was just showing how we got that, and it works. Let's go to question 26. Question 26 reads that a cylinder and a cone have the same volume. If the height of the cone is 24 centimeters, find the height of the cylinder. Let's look at the key fact here. We are talking about a cylinder and a cone, and the question said they have the same volume. It's a very important information. The question went ahead to give us the height of the cone to be 24, and now you're solving for the height of the cylinder. Now, if we let the volume of the two be V1 and V2 respectively, then it means that V1 will be the volume of a cylinder, which is pi r square h. Maybe let's call this one h1 since they have different heights, okay? And then the volume of the cone will be 1/3 pi r square h2, all right? Okay, the question said the two volumes are the same, so that means that V1 equals V2, right? We now replace them with the formula. So pi r square h1 will be equal to 1/3 pi r square h2, right? And then we know h2 to be 24 according to the question. So let's go replace that. Instead of h2, we put 24 in here, all right? Pi is the same for both sides, so they can cancel out. R squared is the same for both sides, so they can cancel out. And we'll have H subscript 1 to be equal to 1 over 3. I want to bring the number times 24. And that will be equal to 3/824. So 8 centimeters. And looking through, that is option B. Let's go to 31, which is the last for this study. Question 31 reads that a sector of a circle of radius 21 centimeters subtends an angle of 120 degrees at the center. Find the length of the arc of the sector. Take pi equal 22/7. As usual, let's get a fact. The radius of the circle is 21 centimeters and the central angle, the angle subtended at the center, is 120 at the center, 120 degrees. And then we have to find the length of the arc of the sector. And as usual, let's not forget this very important information. We'll start right with what we're looking for, the length of the arc. So arc length. I'm going to use L for arc length. So if L is for arc length, the formula is theta over 360 times the circumference of the circle, which is 2 pi r, right? Substituting the numbers. Theta is the central angle, that is 120 degrees over 360 times 2 times pi is 22/7 times the radius is 21. I'm not even going to stress myself because calculator is permissible, so I'm just going to put everything to the calculator and choose the answer. Again, I just put it in exactly the way I see it, and that gives me 44. So our answer is 44 centimeters. And looking at the options, that is option C. And that is where we end today's studies on length, area, and volume. And definitely the next video will be on another group of topics. And I hope this video has been of help to you. If yes, then why not consider subscribing to this channel for more videos like this. Till we meet again in my study room. Bye bye.